called definitions and notations. So it's really, really important that you are able to know these definitions, but even more important that you know the notation for it. So if it asks for a segment or array, you know what that notation looks like, and you can use that in your work, but also look at that from a problem stance. So let's look here. We have the first thing that we're going to talk about is a point. So a point is just a location in space with an indefinite size and shape. Okay, so just a regular point, just kind of sort of hanging out. So it could look like this. This is point P, and so to name it, you would just use one letter. So point P from there. And then a line is a series of points that extends in opposite directions without end. So something that looks like this. And again, it has a series of points. So you can have lots of points on a line, but let's just say that we have point M and N here named on my line segment. Not line segment, just line. So then we would note that with arrows above M, N. So we would know that that continues on after M and N. It doesn't stop there. A plane is a flat surface that extends in all directions without end. So a plane is like the surface of your desk. That is the best definition I can give you of a plane. So when you talk about a point or a line on a plane, you're talking about it being on a desk. Okay, so if that makes sense. So a point on your desk, or just a line segment on your desk, or a line on your desk, that's on a plane. All right, so we'll name this. So if you want to, you could, if this just had a regular, it just is labeled with one letter. So let's say that this is plane L. Okay, so you could name it as that. Or if you had a few different points on your plane, so if you had A, B, and C, you could name it, you would say plane ABC, or you could say plane L. Or you could say plane ABC. So naming three points on that plane. A segment is a part of a line that consists of two endpoints and all the points in between them. So there's an infinite amount of points on a line. So, but I'm going to typically you see a line segment with a few, not infinite amount, obviously, but a few different points. So you would see here. So this is point D, or this is line DE, but obviously there could be another point, somewhere in the middle like that, and that's okay. So you would name this would be line DE. So notice that you don't have the arrows on the end like we did with a line, but it's just a segment showing that there's two endpoints there, and it's naming the two endpoints. Array is a part of the line that consists of one endpoint and all the points of the line on one side of the endpoint. So it's like part of a line. So it's like part line segment, part line, because you have one endpoint. So, and then so typically you would name this, you'd have another point on that line. So this would be ray RT. So you would note it in the direction that is facing ray RT. All right, so if two rays that share the same endpoint that form a line, it's called opposite rays. So, so if we had a ray going this way, that was C, and then we named another point on there at B, and then we had a ray going the opposite direction, starting out at C, and we had another point on there A. You would name this ray either CA or ray CB. Okay, so you could name them either one, but you would name those separately, those two rays apart from each other. Collinear means two or more points that lie on the same line. So any 2 points could be collinear. So co meaning two, linear meaning line. So if we had this, so if I just had a line here, I could name P and Q. So this would be line PQ. So PQ would be considered to be collinear. And then non-collinear, points that do not lie on the same line. So this one, so if I have my M and N, those are collinear. But if I have a point out here, P, that is not collinear with M and N. You wouldn't really name that. Coplanar, 3 or more points that lie on the same plane. Lines can also be coplanar, so if you have 2 or more lines on the same plane. So if I have my plane, let's say H here, then I would have coplanar would mean points. So if I have a point A, a point M, and a point P, then those would all be coplanar. They're on the same plane. So it's like that part of your desk. Now, we'd have to think of your desk extending out all to infinity and beyond, but any 2 points on there be coplanar. So if you could put your Chromebook, your phone, and a pencil all on your desk, those are all coplanar. Non-coplanar points that or lines that do not lie on the same plane. So if you pick your phone up off your desk, okay, then that would not be coplanar. All right, this would be off that plane. Does that make sense? Or if you drop it down the ground, that is not coplanar. So if we had a plane here, and this was plane H, and we would have A and M, and I could have Q maybe out here. A, M, and Q are not coplanar. Okay, so just some postulates here. Postulates mean that this is just kind of sort of understood to be in geometry. So 2 points determine a line. So any 2 points can determine a line. The intersection of two lines is a point. So where 2 lines cross, that's at a specific point. The intersection of a line and a plane is a point as well. But the intersection of 2 planes is going to be a line. 3 non-collinear points determine a plane. 3 non-coplanar points determine a space. Okay, so now we're going to look at this picture here, and we are going to determine all of the points and lines and planes and collinear points and coplanar points. So let's see here. Our points, we would have A, B, C, D, and F. So those are all of our points. Our lines, that's going to be line AD. You could say line AE, and you could say line DE. These are lines with arrows, sorry. And then planes, we have plane G and H. Collinear points, that means they're on the same line. You would have A, D, and E. Those are all collinear points. They're all on the same line. And then coplanar points, which you have on the same plane. So it looks like coplanar points would be D, E, F is some, and then I would say C, D, and E. Those are all coplanar because they're where G and H intersect. That's that line, ADE. And so therefore D and E is on both of those planes there. Okay, so now we're just going to answer a couple of questions about this space over here. We have our points S, O, and Q and M coplanar. So S, O, Q, and M, are they coplanar? And I would say that no, because S is not on a plane. Because even if we were to continue this out, they would not be on that same plane there. They're on plane T. All right. So name the intersection of planes LON and NQM. So basically that's plane R and plane T. So the intersection there is going to be that line, and that line segment looks to be, you could say UN, UO, or you could say NO. So it also says UNO. So the intersection is there because that where two planes intersect, it has to be a line. Name the intersection of plane LNO and line MN. So where, let's see, so basically plane R, and then you have, so plane R, I guess, is facing kind of diagonally there, and then you have your line running through it, and it intersects right here at N. So point N. And then do S and M determine a line? Why or why not? I would say no, because they are not coplanar. So if they're not on the same plane, they can't be on the same line. And then name the intersection of UO and MN. So UO is here, and then MN is here, and so that intersection is going to be right there at point N. Because remember, where two lines cross, it has to be a line. So kind of wrapping up all these vocabulary words, again, this just is a lot different probably than any other math that you've experienced before, but before you long, you'll get the hang of it. Make sure you're kind of remembering that notation for naming points and segments and arrays, so that way you can use that in your geometry course.